Yeah, hi everyone. Welcome to the session of building a modern streaming data pipeline with Apache Flink, Iceberg, and Paimon. So before we start, a brief introduction about myself. I'm Abdul. I'm a senior solutions architect in Bavarica. So Bavarica is the original creators of Apache Flink. I have been working with Flink on everyday basis for more than 2 years. In the past, I have worked as a solution architect in AWS for cloud computing and also worked as a software engineer and cloud consultant and also CTO a couple of years ago. My interest lies in streaming analytics and cloud native technologies. So let's dive into the session. So why this talk? So the reason I wanted to do this talk was that because the traditional batch ETL pipelines, they were good for running batch workloads, batch processing workloads for historical data, but they don't meet the demands of modern data streaming pipelines from today. So businesses need real-time analytics and not stale data from yesterday. So businesses need to make decisions in real time. So that is why there's a rise of new streaming data technologies, new streaming data lakes, data processing engines, data streaming messaging layers, which basically enables the businesses to achieve and have a more up-to-date view of their business in real time and make better business decisions. So there's a rise of streaming data lakes which operate on a low latency and are scalable and cost effective. So the main idea and blueprint of today's talk is to basically guide you how to build such a system using Kafka, Flink, MySQL, or Iceberg or Paimon. Okay, so a brief agenda. What are we going to cover today? So we're going to talk about like why use Kafka and MySQL basically. We're going to stream our events from Kafka, real-time events in Kafka, and we're going to have MySQL as a lookup table. And then we will talk about why would you use Flink for such use cases. Then we will talk about some differences between Iceberg and Paimon. Then we will do a bit dive deep into the comparison and what benefits you can get and how can you use these to basically build your streaming lakehouse. Then we'll talk about an end-to-end architecture, and we will discuss a case study where I will show you how to create basically a simple streaming pipeline using these technologies I mentioned in the top. And then we'll talk about some of the other use cases in the industry and the benefits of streaming lakehouse. Okay, I assume all of you know about Kafka, so I'm just going to touch it on a very brief amount of time. So why would you use Kafka in the pipeline? Because Kafka enables real-time data ingestion, very high throughput, low latency messaging system, ideal for streaming workloads. It decouples producers and consumers, and basically enables flexible and loosely coupled architectures and scalable architectures. The benefits of some of the benefits of Kafka is that it's scalable and durable. You can support up to millions of messages per second, and you can scale horizontally across nodes, and you can do replication in Kafka, and basically you can ensure data durability with disk-based storage. Although there's recently some diskless Kafka topics as well in the market, but yeah, for now we just talk about the other features. So the benefit of Kafka is that you can replay so it retains the data for a specific amount of time, which you mentioned in configuration, and basically you can go back any previous time and replay all the events from a specific time, which is very useful if you want to recover from a failure. And it supports a broad ecosystem with Flink, KSQLDB, DBZM, and much more, and has a variety of connectors of database cloud storage, which it supports. Okay, so we're going to use Kafka basically for getting the real-time events into our system just for ingestion. And for MySQL, we're going to use MySQL mostly as a lookup table. Why I use MySQL for a lookup table? Because it's a widely used, better tested database. You can have your lookup tables like order systems, user profiles, inventory, and everything. And it's also very easy to do change data capture on MySQL using something like Debezium or Flink CDC, where you, instead of taking the backup, for example, for the full database, you are only streaming the row level changes, which are happening to MySQL. For example, you can use CDC to basically gather build logs, change log events, and we can source them directly to Flink and process them on the Flink side. Okay, so now why would you use Flink to basically be the core at the center of your streaming data pipeline? So Flink supports both streaming and batch processing. It supports exactly one. It gives you exactly one guarantees. It simplify the design to basically one code which you can run for both historical and real-time data. It supports event time and stateful processing. It's ideal for aggregations, joining the data from multiple heterogeneous sources and enriching the data in real time. And it has a extensive amount of integration with Kafka, MySQL, CDC using Debezium and Flink CDC. And you can publish event results to Kafka or Lakehouse directly. The most important features why we use Flink is because Flink just supports out-of-box fault tolerance and gives you the tools to handle back pressure and also do scalable checkpointing. And you can also scale it easily as well. Flink also support open table formats like Apache Paimon and Apache Iceberg. It has the connectors for these things as well. So I want to touch a little bit about the difference between Iceberg and Paimon. So what is Iceberg? I hope you all know. So Iceberg is just an open table format for large-scale data analytics data sets. It's basically an open table format which was developed and designed for batch workloads, which gives you acid guarantees when you write your data to data lakes like S3, for example. It supports schema evolution. You can also do time travel. You can go back any point in time and query your snapshots of your data. But keep that in mind that Apache Iceberg was basically designed for batch workloads. It does support streaming workloads, but basically it supports streaming workloads in forms of micro batches. So it's not fully native streaming workloads supporting. So there are some limitations when you're using Iceberg for streaming data, for example. Some of these limitations are that the write path is append only or merge on read. So it's not ideal. It could be ideal for batch workload, but it's not ideal when you have streaming pipelines where you're getting chain data capture. So it does not support write ahead logging for fail-safe streaming ingestion. It's optimized for batch analytics, not for continuous streaming queries. And most of the times when they are small files and you want to do streaming compaction, it's a manual work. Okay. So again, Iceberg is a great tool, but it is very good for batch workload, but for streaming, it does have some limitations. So to cover the gaps in those limitations, that is where Apache Paimon came in. So Apache Paimon is again another open table format which support high-speed data ingestion and change data capturing, which enables an efficient real-time analytics. It closes the gaps which Iceberg has for streaming. So for example, it is a unified batch and streaming platform. It supports both batch read writes as well as streaming read writes. Compared to Iceberg, Iceberg support batch read writes and micro batch read writes basically for streaming. So it has overhead. The Iceberg has overhead, but Paimon supports the streaming read writes natively. It's low cost, high reliability, and scalable metadata. So there are multiple merge engines you can select for Paimon based on whatever your use case is, whether it's a partial update or a full update or primary key, or whether you want to have your queue. So you can choose different merge engines based on your specific use case. Yeah. So this is just a high-level architecture of how would you use Paimon and what are the main use cases for Paimon. So why is it used? Basically, for like any use case like real-time ingestion, where you want to have your sync your full database. It also supports schema evolution, both for uh, batch and streaming workloads. It supports partial update and batch overwrite. And it supports incremental snapshots, changelog, produce changelogs, and we're going to use basically Paimon to do lookup join. We're going to use Flink to do lookup join and write stuff in Paimon. Yeah, I'm going to show you some examples. But before that, I'm going to talk about some of the high-level features about Paimon, which could be interesting. So Paimon makes it very easy to time travel for streaming workloads. So if you see here in the code on the right side, in the DDL, I can specify that I want to create tags. If I have a streaming data coming in, I can specify that I want to have regular automatic tag creation at a daily interval. So what Paimon will do is once it's storing the data, it's creating these tags every single day. It's leaving these tags in your storage. The benefit of it is that you can at any time I can query any specific tag, which means I can basically query my table snapshot at any specific point in time. For example, if I want to read the latest snapshot, the last one, I can write like let's start from this table. But if I want to maybe read whatever was the state of my data at a specific point in time, I can give like the version of this tag here, for example, this date here. And if I want to maybe read only the incremental data between two tags, I'm not concerned with the previous and the later data, only the incremental data between these two tags. I can use this Paimon incremental query function to basically read incremental data. The benefits of this is that it helps you to do data backfills, and basically you can query the table snapshot any point in time. So compared to Iceberg, it supports CDC lake ingestion with schema evolution out of the box. So, for example, if on your MySQL, if your data pipeline already ready, and on MySQL you need a new column, then that column will automatically be synced on Paimon without you needing to do anything. So this is schema evolution is also supported by Iceberg. So I think here is not too much difference. Some of the other benefits which you can get directly using Paimon is you can do data disorder handling. You can, instead of having a full update on records, you can, based on whatever merge engine you have selected, you can choose partial update. And for example, if you have partial update engine here, and I'm inserting some value in this table, and then I have this sequence that for partial for the fields G2, for example, the sequence CD. So CD should only be there if there is something in G2, and if I pass G2 as null, that value will not be updated. So you can define a lot of rules, which basically you can update previous rows without affecting newer records. So it can basically help you improve the data quality and backfill the data when you have the updated data. Another very cool feature for Paimon is that it supports async data lookup. So, for example, if you have a lookup table, you can configure, instead of writing the code, you can basically set up this configure async option like this, like lookup.async true, and you can specify that whenever, for example, if there is a lookup table and lookup table does not have the updated entry yet, whenever there is an update into the lookup table, it will just basically get the result, and it will propagate the changes all the way down to your data pipeline. Yeah, so you can also, as I mentioned, there are multiple merge engines you can use, which basically store the data as you define. For example, if you use the first row merge engine, so you will always keep the first row as the same as the primary key, which means if you want to do deduplication, you don't have to basically whenever if you have a one record coming in, if you have multiple records against one specific primary key and you want the most recent one, so you don't have to always do an aggregated query of min max or using any row or window function. It is keeping the first row as on the storage level, which means when you basically query, it will just fetch you the first row directly, which means you're doing deduplication without actually writing the code for deduplication. It's a very powerful feature. So if, for example, you know that you're going in a specific table set, you want to basically in the future do aggregated functions on some specific columns. For example, if I have a sales table where I have price and sales, and I know that I'm going to do min or max on specific columns in the future. And if I use the merge engine as aggregation here, and or specify the aggregated column configuration here, the moment Paimon is storing the data, it is updating the min max at the same time, which means at the time of the query, when I'm querying the data from Paimon, it is all calculating the min max at that time. It already has the most recent, the latest min max, the most updated value in the storage as well. Okay, that saves a lot of time in terms of performance. So you always have the most up-to-date result in your Paimon storage. Some of the benefits of Paimon which you can have is you can basically use Paimon to replace your Kafka completely. Okay, so you can get rid of Kafka completely. The benefit you will get is it gives you much lower cost and simplified operations. You can use that as an alternative to Snowflake as well, where it basically supports materialized queries. So on Kafka, everything is the logic or the processing, everything's actually being done on the storage level the moment it is being stored. Okay, which means storage is cheaper than compute. Okay, so you have to do less compute every single time when you are doing a query, an aggregated query, for example. So it's cheaper in terms of cost and better in terms of performance, and your results are always up to date at latest time or any specific point in time. Whether you want to do min max, for example, any specific point in time, it won't have to calculate it once you are executing the query. All the processed aggregated results are always there on the storage level. You can use it as an analytical engine with Flink. You can leverage the merge aggregation support. It's a low-cost operation using with Flink, and it also helps you avoid a large state. So some of the comparison between some of the use cases and where would you use Iceberg and when would you use Paimon. So for streaming ingestion, you would use Paimon. I mean, you can use, of course, both, but Iceberg does not support streaming natively. It supports streaming in micro batches. If you have an OLAP or analytical workload which you are doing on which you know that you're only going to do it on historical data, you can. So Iceberg is best fit here, but Paimon is good fit in this case. When you do want to do real-time lookups, that is where Iceberg has some limitations in terms of real-time lookups, but Paimon has a strong support in this case. If you're doing change level semantics, so basically on Iceberg, you're only doing insert only, but on Paimon, it supports the full insert, update, delete, changelog semantics. On streaming compaction, Paimon has built-in, but Iceberg does not have built-in streaming compaction. You would probably need to use some external frameworks like Flink or Spark to do compaction. Paimon does support write-ahead logging, which is very beneficial for stream processing, but Iceberg does not support write-ahead logging. For streaming reads, Iceberg is more batch-friendly, but Paimon is basically actually doing real-time changelog support. For CDC integration, you need to use something external with Iceberg, but with Paimon, it supports it directly. And yeah, for example, for Iceberg, you would need to use Flink CDC in combination with Iceberg, but Paimon supports it directly. Yeah, Paimon has a built-in catalog, but for catalog in terms of Iceberg, you would need something external like Hyperglue. Okay, now I'm going to cover an example use case. Example use case I'm going to cover is to basically find the abandoned cart in your shopping cart. So, for example, ecommerce.inc is a company, and the user experience it's an e-commerce company, and where the users are actually going and buying different stuff online. So now we want to pick out those users who added a specific product in their cart, but they did not check it out. Okay. So as a user experience experts, what they want is basically, I want to send an email to that specific set of customers who basically added something in the cart but forget to check it out. So now how to implement that use case? What do we need? We need a stream of events, a stream of clickstream events coming directly from the website. We want the user information, which will be in the lookup table in MySQL, and the product information, which will also be in MySQL table. And the stream of events, the clickstream events will be coming from Kafka. Okay, so how would you design this pipeline? So we would have the Kafka capture the real-time events of all the clickstream logs. Flink will basically read the data from Kafka and enriches it using MySQL data as a lookup table. And Flink will process the aggregation. The output goes to Iceberg or Paimon tables, and then we can query those using Trino, Hive, or Spark. This is a use case in terms of architecture. So on the left, this is the full architecture you can see. So right now, just for this scope of this one, we don't have real data coming in. We are generating dummy data for users and products. And whenever there's a change in the user or product, change data capture is triggered via Flink CDC and basically going to a Flink job. And here we have all the events which the user is clicking. So events has all the clickstream events where user is clicking any different place on the website, where it's add card, remove card, whatever the user is doing on the website is being tracked in the events. So again, as I mentioned, the data generation part is right now is already, we're gonna do data generation ourselves using the Verica platform, or you can use any other data gen tools you can use. The data is being generated and goes to the user's products and events. In the real world scenario, you will have the data coming in natively directly. You don't have organic data. You don't need to generate this data. And once the data is there, then we're gonna filter the events which are useful for us. For example, the clickstream event, the clickstream data is a lot of data where the user is moving the mouse, where the user hovers, click everything. But we are only interested in the ones where only those events where basically user is adding something to the cart and just not doing anything. So when I first use Flink to basically filter out the useful events, so we can use open source Flink, or you can use Verica to run Flink as well to basically filter out the events. And once you have the events, you can basically generate the abandoned events. So then we're going to use Flink to basically sessionize our events and then do an aggregation and find out what were the abandoned events in that specific time window which we mentioned. Okay, so once we have all the abandoned events, we're gonna do a join between these abandoned events and MySQL CDC here, and we're gonna enrich them using MySQL CDC as a lookup table and write the actionable events in Paimon. So here you can write the actionable events in Iceberg as well, Kafka as well, whatever you want, which can trigger your next kind of pipeline. This is how the Apache Flink job for this pipeline looks like. So you have the operator for MySQL here, and then you have Kafka here, and you're gonna join these two via an inner join, basically a lookup table, reaching your Kafka and writing everything in Paimon here. Some of the other use cases for streaming Lakehouse are in banks. You can use it for fraud detection. With enriched events, you can use real-time balance and transaction analysis. In retail industry, you can use it for real-time inventory tracking and restocking automation. You can predict customer journeys, just like we did for abandoned cart. And for logistics, you can do real-time package ETA monitoring and telemetry stream ingestion. Some of the benefits for streaming Lakehouse. Again, just a summary of whatever we have discussed today. So you get real-time insights and decision making. You can have unified streaming and batch architecture. You write same code, same architecture, same stack for both your batch and streaming data. You can provide asset guarantees. You can do streamless data evolution. So basically, you can run your streaming Lakehouse at scale in a very cost-effective way in sub-second latency. So that is what everyone is moving these days. So basically, moving from batch and warehouse to stream and Lakehouse for basically making your business truly agile compared to competition. So I think that's all I had today. Thank you so much, everyone. I'm going to answer your questions in the chat. So let's see over there. Thanks a lot, everyone. I hope you learned something new. Yeah, hi, everyone. So I'm happy to answer any questions you have.
Hi, Abdul. Thanks for joining for the live Q&A. I didn't see any other questions come in. The one question, just so it's part of the recording, was how do you compare Paimon and Iceberg? But we saw that detailed table that you had. I wanted to ask a question about, so I think the architecture diagram, you show Paimon as the final output after the Flink jobs. Can you kind of contrast that to all of the Flus work that's going on? Is Flus more on the front part of the diagram if you wanted to completely replace Kafka as kind of the input of the events, where Flus might be at the beginning and then Paimon could be at the end? How would you use those, or how do those
Okay, understood. So Flux is basically working on top of Apache Paimon. Okay, so basically under the hood of Flux is Paimon somewhere. Okay,
Paimon? Okay.
so yeah, exactly. So which means you're gonna use Flux or Paimon. You can use it at the start of your pipeline and at the end of your pipeline. Okay, so basically you can use that to fully replace Kafka as your streaming layer, as your message queue, as your storage layer. And basically it just it's cheaper to run. It saves you a lot of cost, and you're not doing all the aggregations in processing time. Okay, you have all the aggregated data, everything is being stored there at the time when the data is being written. It's storing. Okay, which means any aggregated query you run from the end, it will be always very quick, the cheapest, and the high with the lowest latency. So basically, talking about Flux and Paimon, it goes together. So Flux is on top of Paimon, and yeah, you can use basically at the source and the sink as well. Basically, you can use it to fully replace Kafka.
So what additional features would Flus have if people were like, I like Paimon, or I need to choose between the two? Why would you go with Flus versus Paimon? What does Flus add on top of it?
I have another question as well. Okay, so keeping the just let me read the question. Keeping the events in column instead of Kafka as rows. Okay, so basically what Flux adds to Paimon is streaming compaction, deduplication, auto-tuning. So Paimon, you still have to, again, configure the tuning. How do you tune, do some performance tuning in Paimon as well. But if you're using Flux, it's just doing all the tuning automatically, which means it's optimizing itself automatically. So based on the access pattern, it's optimizing the underlying usage of Paimon automatically. And it helps you manage small files. The compaction is the biggest problem we have in Iceberg. When you have a lot of small files, then doing compaction on them is very hard, and it's a lot of manual labor, manual work. So Flux and Paimon basically makes it easy to do all this compaction of small files in real time, basically reduce latency, and just simplifies the operation when you want to have any application with a real-time use case. So it could be it could be any use case whenever you have a real time. Which means basically Paimon, think of Paimon as an open table format optimized for storage as for your underlying storage, but Fluss adds some more thing on top of Paimon, which is not just storage, but also some optimization which makes it easier and tune it automatically.
The other question I had was that if you were to work with Viverica as a customer, is Paimon built into the system as one of the options? How does that work?
Yeah, so it depends on which product you use. So for our on-premise platform, we have a Paimon connector, which basically you can use, and you can use Paimon as a source and sink. And for so here you can basically add Paimon connector in Viverica on-premise, and for our cloud offering, the Paimon comes built in, which means you don't need to do anything extra to add as an external connector. So Paimon just comes in, it comes just built in. You can use Paimon just from your very first job without needing to configure anything. All you need to do is just configure what is the path of your S3 storage where you want to set up the Paimon table. And don't need for any other configuration for connectors. If Viverica Cloud just supports it directly out of the box.
Awesome. I see that another question came in. Let me see. Comparing Paimon versus Time Plus.
Comparing Paimon versus what?
Time Plus.
I want to see this question. Where are you getting this?
In the Q&A where you answered the previous question during the talk. A question came in.
Okay. Okay, Q&A, okay.
Yeah.
Oh, okay. So how do you compare Paimon to a streaming database like Time Plus? Okay. So I think the biggest difference is in terms of like open source. So Time Plus is a commercial SaaS database where you need to pay a license. It's proprietary, but Paimon is open source. You know what is going on under the hood. And what else? So Time Plus is only suitable for streaming workloads, okay? But Paimon is optimized to run both streaming and batch workloads, both of them together, okay? So Paimon is basically built on top of Apache Flink, Spark, and like Trino and all the like the open source stuff. But for Time Plus, it's just basically a proprietary commercial tool, which basically does support Kafka and Flink, but again, you have to pay the license, and again, it's not open source. Yeah.
I think we're out of time. The next session is probably going to start in about 1 minute. Anything else you want to close with?
If there are no questions, I hope everyone enjoyed and learned something new today. And I hope there's a lot of noise around Iceberg and Paimon, what is going on in the market these days. So I hope I could clear and answer some questions. And if you have any more questions, feel free to reach out to me, and happy to answer any questions you have or help you in any workload or any use case you have.
And as we hear more about Fluss, thanks for clarifying that they are very closely related together.
Definitely.
All right. Thanks.
Okay.
Thanks, everyone. Thanks, Abdul, for coming to the live Q&A and the presentation.
Thanks, everyone. Have a nice rest of the.
Thank you.